Today we are going to talk about how to solve polynomial equations. And what this really is it's an extension of what we did with quadratics. So let me just give you a quick example of something that we solved before. So if we had a quadratic like this, we can factor this, we can use the quadratic formula, we could complete the square if we had to. It's not very fun. But let's go ahead and factor this. So this factors into, let's see, they're both plus. Factors of 12 that add up to 7 are 3 and 4. So we factored it, and then what we did is we set them each equal to 0. So either x plus 3 equals 0 or x plus 4 equals 0. And then we subtract 3 from both sides. We get x equals negative 3 and x equals negative 4. So we did that when we did our quadratics, factored a bunch of different things. So we're going to just continue with that idea, just with more complicated problems, more complicated factoring problems. But the process is no different. We're going to factor things, we're going to set all the factors equal to 0, and that'll be our solution. And we are going to go slightly out of order on this because number 1 and number 2 are kind of the hardest ones. So let's take a look at number 3. We can start there. So we want to factor this thing. The first thing hopefully you notice is it has a GCF. We can factor out an a to start with. And that'll leave us with a squared minus 9a plus 14. And then we're going to keep factoring that because I'm pretty sure we can. The signs are going to be the same, and they're both negative. I'm looking for factors of 14 that add up to negative 9, and it'll be negative 2 and negative 7. Now that it's factored, I'm going to take all of these factors and set them equal to 0. So either a equals 0. Oh, sorry, that was not quite right. A minus 2 equals 0, or a minus 7 equals 0. And then we just need to solve these quick, which won't take long. A equals 2, a equals 7. So my solutions are 0, 2, and 7. I have 3 of them. Okay. All right, let's go ahead and try number 4. Now, the only way that this method works is if it's equal to 0. So the first thing I want to do is subtract the 3x squared from both sides. Okay, that's my cursor. That's not anything we have to worry about in the problem. So we get x cubed minus 3x squared equals 0. Then I'm going to factor out my GCF, which is x squared. That leaves me with x minus 3. Then I'm going to set those both equal to 0. So either x squared equals 0 or x minus 3 equals 0. Now I'm going to take the square root of both sides. Now when I introduce the square root, I need to do plus or minus, but plus or minus 0 is just 0, so it doesn't really matter. So I get 0 and 3. And those are my 2 solutions. All right, well, let's check out number 5 and 6. So for number 5, we're going to start out just like we did before. We're going to factor out our GCF, which I believe is t squared. So that leaves us with t squared minus 3t minus 40. And then we're going to keep factoring that. So these are both going to start with t. The signs are different this time. And now I'm looking for factors of 40 that give me negative 3. So I think negative 8 and positive 5 will do it. Once it's factored, you're going to take all of your factors and set them equal to 0. Now, if you can do this step in your head, you're welcome to skip it. You don't need to write it down. When I take the square root of both sides here, I just get 0. I'm going to add 8 to both sides and get 8. I'm going to subtract 5 and get negative 5. So those are my 3 solutions. All right, number 6, same thing. It has a GCF. The GCF is b, so we'll factor that out. So we have b squared minus 8b plus 16. And then we'll keep factoring. It's going to be b and b. The signs are the same. They're both negative. So I'm looking for factors of 16 that add up to negative 8. So negative 4 and negative 4. And now that's factored, I'm going to take each of the factors and set it equal to 0. Now, I have b minus 4 equals 0. I have another b minus 4 equals 0. We don't need to do it twice. It's going to give us the exact same answer. So add 4 to both sides, and our two solutions are 0 and 4. We'll go back up and catch number 1 and 2 in the next video.